Please welcome Chainguard's Chief Marketing Officer, Liz Egan.
Good morning. Welcome to Assemble. This is our second annual conference. Thank you for being here. Today we are focused on the future of secure software development. And we have assembled an amazing day for you, full of product announcements, hands-on workshops, and a little bit of fun. So the name Assemble has multiple meanings. It means bringing groups of people together, which we've done today, and assembling software components in modern software development. And what a year it's been in software development, so much change. So that's all the more reason we wanted to get the smartest minds together to think about the future of software development. And that's exactly what we're doing today. So look around you. You're in a room with hundreds of engineering and security leaders, and thousands more are streaming in online. Together, you are building the future of secure software development, and Chainguard is privileged to be part of that journey with you. So, to kick things off, it is my honor to welcome Chainguard co-founder and CEO Dan Lawrence to the stage.
Thanks everyone for joining us here today. There's this saying, or meme, or rumor, or urban myth, or something like that, that every software engineer secretly wants to retire and become a woodworker or a goat farmer, or something like that. Is that true? Does anybody here want to retire and become a woodworker? Yeah. I understand it. I went through a little woodworking phase myself. And then I started Chainguard, so I got a little busy. But I was working at Google for a long time before we started. And when COVID happened and they realized the whole bending the curve thing was going to take a little longer than we thought and people were going to be stuck in their houses, they had this nice benefit where they gave us like $1,200 to get a nice desk and chair and home office set up so we could be productive at home. I had this brilliant idea to, instead of buying a desk, buy a really nice table saw, and then I was going to build all of my own furniture. About $25,000 later, I had a bunch of shitty furniture throughout my house and a table saw I never use anymore. But I do get it. It's fun to work with your hands. How many people are thinking about becoming a woodworker, especially now with all of the change in our industry and AI putting our whole future in question at the same time? Yeah. Does anyone want to come up and try a little woodworking today before we get into all of that scary stuff? I need one volunteer. All right, come on up.
On this episode of This Old House.
Can you put this on?
Okay.
This is going to go great.
Fits so well.
Here, I'll help. I'll help. There we go. Is that too tight?
No, it's perfect.
Okay. All right. You're going to cut that.
With this?
Yeah. Safety first, though.
Okay. Pretty good.
I'm going to hold it for you.
No.
You're getting there.
Idea? Any help? A little cheering might help.
Almost there. You can keep this. It's yours.
Thank you.
Isn't it great to work with your hands?
What a gift.
Hand woodworking is especially fun because you get to spend time, you take your time cutting, it's hard to hurt yourself. It's harder to make mistakes because you're going slower. But it's not as much fun as when somebody finds one of these and then starts doing work 10 times as fast as you were. I wanted to do this to prove a bit of a point. I also wanted to see if our marketing team would let us bring a power tool on stage, and they did. But I think this is a pretty good illustration for where we are as an industry right now. We've all been writing software by hand for the last several decades. And just like hand woodworking, that gives you time to be familiar with the code, time to understand what you're doing. It's harder to make mistakes because you're going slower. But in the last couple of years, everyone's gotten power tools, like this saw. It's a lot of fun. You're cutting a lot of wood, but it's also a lot more dangerous. We've been getting access to them for the first time with tools like Codex and Windsurf and Claude Code and all these fancy autocompletes. They're a lot harder for us to grapple with as an industry because no one's been trained on how to use these power tools. Thank you. But they're fast and they're a lot of fun. And that's why everyone here is using it. So show of hands, who's using AI when they write software today? This is a safe space. Whose security teams are happy you're using it? Good. Security is not allowed to say no to this. This is something that's so powerful, we have to find a way to use it, even if it does scare us a little bit. All right, one final one. Whose security teams are using AI? Decent, but not enough. Fortunately or unfortunately, that side of it's going to have to change because everyone here is using AI, and if we're all using it here in this room, the bad guys are too. The only real bottleneck into breaking into systems previously was patience. Everyone knows a sophisticated enough attacker that spends enough time could break into pretty much any system out there. Now agents are giving attackers basically unlimited patience. The only bottleneck is tokens. Developing an exploit for a published CVE used to take months before one of these was published. Now that's measured in hours or days at the latest. RSA is next week, and there's going to be a bunch of agentic pen testing companies showing how they can develop a chain of exploits to break into complicated systems in the time it takes to get a cup of coffee. That used to take months for the most sophisticated attackers out there. The old flow of 30, 60, 90-day timelines to detect a CVE, file a JIRA ticket, nag, and nag, and nag, and eventually patch it. That's going to go away quickly. We're not going to be able to wait that long when exploits move that fast. So power tools can be used for good and bad, and we're going to need the good ones to start using these to keep up with the bad people. So sum this up, the era of scan and file a JIRA ticket and wait and wait and wait and eventually patch is over. The only way to keep up here is automation and starting with something that's secure by design. The crazy part is we're not stopping here. These power tools are a lot of fun, and a lot of the industry is still transitioning to them. But I don't think we're going to be here for very long. I'm not saying the power tools are going to go away, but I do think that in the next 12 months, the majority of code is going to be written something different and something new. I spend a lot of time playing with this stuff myself. I'm probably in the top 10 user dashboard for Claude Code if they measure that by tokens. I hope they don't. But tools like Gastown and all these other multi-agent frameworks have shown all of us that the future is here. Agents can now call other agents, and you can delegate, and you're not the bottleneck, and your keyboard isn't the bottleneck either. I think we're starting to develop a pretty good sense of what this is going to look like. I think a year from now, we're going to look back at this time and say, this was the best time in the history to be writing software, but it's also the worst time looking forward. Things are only going to get better from here. It's going to be very different, but a lot better. We're entering a world where these power tools are still going to be around, and we have to figure out how to use them safely, not like today where it's like swinging 6 circular saws around on a jump rope. We're cutting a lot of wood, but we're also losing a lot of limbs along the way. We need to move to something like automated assembly lines where security and compliance and trust are built in, and we need to do that quickly. We're doing that here at Chainguard, and we're excited to show you how this is letting us move faster. We're excited to show you how this is letting us make our products that you already love better, and how it's letting us build new products faster too. This is changing the code we all write inside of our companies, and also the way open source is built and maintained too, and we sit at that intersection. And I have a lot of guesses here, but my guesses are as good as anyone else's on LinkedIn's. So I want to invite up a good friend of mine to talk a little bit about how he thinks open source is going to change in the next couple of years. So I want to welcome up Dan Gillespie, member of technical staff at OpenAI, to chat with all of us. So Dan and I have known each other for about 10 years, and we first met in open source. A lot of people know that one of my first open source projects was Minikube, but there's this little known secret, which is that I actually stole it from Dan. Dan had a startup going at the time, and had built something like that, and I think they got sick of maintaining it, so they handed it over to me. Yeah, let's talk a little bit. What have you seen change in AI and software development over the last couple of years?
I mean, I think in the beginning we had some sort of pseudo AI where you do tab completion, and using statistical models, you might be able to say, okay, let's complete this function and like this method call. But you could only do like one portion at a time. And then we started seeing with GPT-3 the ability to do like translation, where it's like you give it a fully functioning program and you translate that to a different language. And then I think you enter this next era where you can do tab completion of entire functions themselves. And then the chat era, and now we're in the fully agent era where it's off doing its own thing and you're not interacting with it at every step.
Yeah, I think a lot of people forget, but Copilot and some of those LLM-based auto-completion tools were actually the first consumer LLM product. ChatGPT came out a lot later than that. So this isn't really new for software, but why do you think now it's all of a sudden scaring everyone and changing everything?
I think because it's starting to take on more of the full life cycle of software. It used to be this was like purely augmenting the developer themselves, but now it's getting into architecture and the entire structure of programs and making it so that you can just start with an idea and let it go, which before you had to have a pretty clear idea of where you're going with it. Now you don't even necessarily.
Yeah, the scope of them has gotten bigger. Like the first couple demos of Copilot that blew my mind were where you could like write a doc string and then the function would just appear 8 or 9 lines later. But now you don't even need that. It's idea to fully functioning app. What are you seeing change in open source itself as a result of this?
I mean, it's definitely contentious, right? Different projects have different standards. I think there's people who say, we're not going to do any AI code. We don't know how to deal with this. Until we figure it out, we're just going to leave it as it is. I think you're starting to see more people say, okay, AI code, but we want to see your prompt. We want to see how you got there. And then I think we're probably going to move to an era where you just put the prompt and the generation's actually performed on the open source project side so that they can actually have some sort of compliance about what's in there, and you didn't say, inject this vulnerability, or you see the recipe, so to speak, of how you got there.
I can think of very few things I would be more embarrassed to show everyone than my prompts. I am not proud. We get to a good result, but there's a lot of back and forth.
We're going to have to work on our English skills,
Yeah. So where's the future going to go? Like we're seeing this bifurcation. We're seeing some projects ban open source. We're seeing some lean in. We're seeing some take this middle ground stance. And it's not just the code either. Right? The curl project has famously banned AI-generated vulnerability reports over the last couple of years because the volume of those has led to basically a denial of service attack on the security team's ability to review vulnerabilities. Where do you see this going?
I mean, I think we're in a middle ground era, but I think the popular projects will have to keep up, because why do you reach for open source? Is that it enables you to do something relatively easily that you couldn't have done before. And with AI generation, you can very quickly push that boundary of what you can do in those projects. So the most successful projects will figure out a way to bring in AI contributions, maintain the trust that what that code is doing is what your users expect, and be even more successful for it.
Yeah, I think trust is kind of that key piece. When we chatted yesterday, you had a good framing around this. The bottleneck isn't code anymore, it's establishing trust. What are we going to have to do here to establish trust? There are projects like Mitchell Hashimoto's kind of vouch thing, where it's this distributed almost PGP network where people can vouch for each other to determine who's trustworthy. But then there's the other side too, where you have no idea who's running those prompts or if you can even trust those prompts. Everyone in open source is a stranger on the internet. It's like that old meme where you don't know if the person you're talking to is a dog or a Russian nation-state attacker or something like that.
Yeah, no, I think this brings into a really good point, which is like the review side will now become the hard part of open source. It used to be that the authoring, the architecture, putting it together was the hard part. Now, like just making sure what comes in will be the hard part. And I think the way you have to maintain trust is have trust in your instrumentation and your processes for taking in those submissions, validating them, and really putting them through the ringer. And I think we're behind in this area. I think that we're going to see a lot of innovation here, which really pushes any contribution that comes in and tests every piece of it possible. And I think probably we'll see our validation infrastructure becoming more complicated than the code itself potentially.
Yeah, we caught up a few weeks ago to chat about this a little bit, and I asked you, like, when's the last time you wrote code by hand? This is changing, that same trust framework also applies to code we're writing inside of our companies, but open source makes it a little bit harder.
Yeah, it's been a while. You know, in terms of like purely just opening up a file and writing out every character, it's almost been years now. Maybe for like tiny things, but even then, it's hard to justify the time it takes to do that typing versus the typing of the prompt.
It's like cutting a piece of wood with a handsaw. Hard to justify doing that. Yeah. And code is just one piece of this open source problem too, right? Even if you had the code, getting that to something you can actually run has a lot of links, and those are getting swamped too. We see AI-assisted attacks swamping NPM with malware packages constantly. Where do you think the future goes with the trust of the entire supply chain as things get in?
I think we just need to scale up processes that are adding rigor to every step of where code goes from being written to being deployed. And at every step, doing more and more validations, which I mean, obviously, a lot of what you work on every day comes into part. I think that's just going to explode. Like, that's just going to be the most important part of coding and software in general, is just maintaining trust that what you're running does what you expect.
Yeah. All right, shameless plug time now, and then we'll wrap up. In this new world, do you see what we do here at Chainguard as being more important or less important?
I think I gotta say more, right? Yeah. You know, I'm here, right? No, I really do think that. I think that the amount of doubt that can go into what you're actually running has only increased with these changes. And it becomes even more important to know what process did this code go through to get onto your computer, onto your servers. You need to know that, and you need to know that with a cryptographic authenticity that is essential. Otherwise, you just have no idea, and you're just giving up control entirely in a way that we really have never seen before.
The volume of all of this is turned up to 11. Yeah.
Absolutely.
Well, thanks for joining us today, Dan.
Thank you for having me.
Yeah, thanks for coming. Thank you again for joining us, Dan. OpenAI is one of the many organizations that became Chainguard customers last year, and we love all of you. At this time last year, I was on stage at Assemble, and I shared that we had just passed 150 customers. Right now, we're nearing 500 of all of you. And I give you all a big thank you for trusting Chainguard with the most critical parts of your supply chain. Let's give you all a big round of applause. It's not just the customer count that keeps us here every day working at Chainguard, though. It's the scale that we're operating at means that we can do a lot more for all of you. More customers using more of our images and more of our products means more open source software that we can secure, and more time savings that we can pass along to all of you, and more risk reduction that we can pass along to all of you as a result. Last year at Assemble, we pulled some stats, and it showed that we had eliminated over 270,000 CVEs from customer production environments for folks using our images. That's 270,000 CVs of hour savings, of risk reduction, of time you can then reinvest back in your own products to make them better for your customers. Today, that number is over 1.5 million. It's 1.5 million more vulnerabilities removed. That much risk reduction, that much time savings, and that much more time you can spend on your products for all of your customers. So I want to give you all a big thank you for believing in us, but more importantly, for all of your feedback and direction. Working with all of you has helped us shape all of the rest of the announcements that we're going to be sharing today. So we're all very excited and very grateful to be working with you all. One more big round of applause for all the Chainguard customers. So we're going to be sharing a lot of things today. I want to start by talking a little bit about how we're using AI in our products, especially over the last year. And to do that, I want to start with this core fundamental piece here at the bottom, the Chainguard factory. The factory is the infrastructure we use to build, patch, rebuild, repatch, test, and eventually distribute all of the artifacts that we sell today, from our OS, to our containers, to our VMs, to our libraries, and to much more that we're announcing later. This year, we rolled out the second generation of this factory. We came up with this brilliant name for it called Chainguard Factory 2.0. In a minute, I'm going to tell you how we rebuilt it and redesigned it using a new reconciler-driven agentic architecture full of buzzwords that we open sourced as a project called Driftless. But first, I want to explain what the factory is and what it does. So going back in time, when we first started on Chainguard images, we knew that we were going to need to build a full operating system if we wanted to have full control over the supply chain. Because the only way to have any trust in the supply chain itself is to build everything from source. It's the only way to be sure that we can keep out malware and have the ability to patch vulnerabilities at any layer in that complicated dependency stack. We knew this was going to be hard, but we probably didn't quite realize how hard it was going to be. We might not have tried it if we realized that. As we got started on this, we knew that this operating system was going to have to be a little bit different. We wanted to be able to package multiple versions of all programming languages and runtimes and compilers and tools that your engineers want and deserve to be able to use. We wanted to be able to package the entire C and CF landscape that changes and grows weekly still. We wanted to be able to build all the software your developers want and need to use without making them fall back to curl pipe to bash. We didn't want to have to call it quits where most other Linux distros do today. So we built an automated system for doing all of that. We knew we weren't going to be able to do all of this by hand. And we didn't really overthink it. We did put some thought in and design, but we built a system for what we needed at that time. This is what it looked like, as you can probably imagine. Everything flowed from left to right, and it was event-driven. As new versions of software got released, we triggered workflows to grab those new versions, kick off builds, kick off tests, change them if we needed to, and get them rebuilt and packaged in all of our containers and other artifacts. As new compilers came out, we triggered workflows to rebuild everything dependent on all of those to make sure you're getting the latest performance and security fixes from the toolchains. As new CVEs got published, we kicked off workflows to query our database, figure out where all of those CVEs were in all of our different software, and get them all patched and out to you as quickly as we could too. All of this flowed from left to right with events. We improved this a lot over time. It wasn't one static factory. We rebuilt entire portions of it as it was running. And it served us pretty well. But as our scale grew close to 2,000 images, tens of thousands of operating system packages, and hundreds of thousands of language libraries, it started to run into problems. Things like dropped events, flakes in automation, missing updates from packages. Those have cascading effects in an event-driven system like this. Every time something would come back online, we would swarm all the downstream systems and run out of GitHub API quota and swamp everything after this. Things get out of sync pretty quickly. And frankly, after all of these revamps and rebuilds and things we had put into the factory over time, it started to look like most CI/CD systems do, full of duct tape and baling wire. We were also starting to figure out a place to put AI agents into this as they started to appear and get useful. But with this architecture was hard. We were trying to cram them in inside of every single one of these event bridges and wrap everything with manual retries. So earlier this year, we went back to our drawing board, and we thought a lot on how we'd rebuild this all if we wanted to start again today. And we went back to our core and took a lot of inspiration from the Kubernetes project. We switched from this edge-driven or event-driven system to something reconciler-based or level-driven. This solved a few problems for us all at once. It makes the system much, much, much more reliable, where instead of failed events clogging dead letter queues and having to wrap everything with retries, we have a whole series of reconcilers that continuously try to move things from actual state to desired state. And that's also a perfect application for agents. They can survey the environment, figure out where we are, generate a plan to get a little bit closer, and execute on that, while we still keep humans in the loop in every one of these reconciler loops. At its core, this allows us to change the way that we prompt and drive our system. Instead of triggering a workflow or asking an agent to patch a CVE in this piece of software, we write prompts and have systems that say, keep all packages free of CVEs, and then divide up that work and get to it. So this is a factory that we've rebuilt with this agentic architecture, and we can give those agents more and more skills over time to make the factory better and better and smarter over time too. All of the failure cases and places where humans have to override the agentic work, we can feed that back in and make the factory get better every single day. Even the days where our friends at OpenAI and Anthropic haven't released a new model that does that for us too. Agents are doing the work in here now. Our team is checking on it and making those agents better over time. So this is a bit hypothetical and theoretical, so I want to jump into an example now on how those agents and this new architecture have helped us improve the product for all of you. And this is probably the most boring example I could come up with, but it's a really good one to showcase this work. And this is version updates. Open source projects release very often, and we track a lot of open source projects across our operating system. We also have a lot of automation today to try to detect those releases. Last year alone, we tracked 21,000 dependency updates across all of the dependencies in Chainguard OS. Now those magnify a bit. This might sound like a small number, but all of those things are really deep in the stack. So every time one of these dependency updates happens, that's used and multiplies by all of the things we have to rebuild after that happens. This 21,000 dependency updates turns into over 500,000 container builds that we have to publish as a result of some piece of software changing. At that scale, getting behind on a few updates can affect huge portions of the catalog and delay version updates for all of you. And unfortunately, our existing automation wasn't perfect. Edge cases start to pop up more and more often at this scale, especially when you're dealing with open source. So if you're an engineer here, I really hope you're saying, come on, this can't be that hard. And this is why I love engineers, because I thought the same thing. It shouldn't be that hard, but it is. Here are just a few examples of the crazy way projects tag releases that we have to deal with. Things get spread out across multiple repositories in the same organization. Maintainers forget to tag some of the repos with the new release. Sometimes maintainers add a V prefix to the version number. Sometimes they forget to add that. Sometimes there's a release hyphen. Sometimes they change the repository that releases are coming from and move it around in a GitHub organization mid-release without telling anyone. All of these cases can get hard-coded automation confused. Now, I hate Semver with a passion, but sometimes I wish we could still pass some universal law requiring all projects use it, just so everyone is doing the same thing. But unfortunately, open source doesn't work that way. So here's what the new agentic architecture looks like. This is actually one of the first production systems we rolled out with agents in the loop. And there are a handful of data sources around the internet that all eventually agree on new versions of software, but we don't want to have to wait for them all to agree. We have an agent in the loop, and that calls a whole bunch of custom tool calls to query data sources like releasemonitoring.org, end-of-life.date. It can even search the GitHub organization to see if things have moved around in that GitHub organization. And it can query the GitHub tags and the GitHub releases, because people are never consistent about that too. We run this for all of the software every day, and it queries all of these data sources and produces a result. We keep a human in the loop here even today. Sometimes we see something unusual, like all of a sudden the repository for a project that has the most up-to-date version changing, or an unusual data source getting the update first. But at this point, after running this just for a few months, we've now built up the world's most up-to-date and accurate database of release information for open source projects, all using this framework and these agents. To step back a bit, though, because I find this stuff incredibly fascinating, but it has real impact for all of you. In the first month after taking this system live, our new automation more than doubled the amount of packages we were able to track without having manual intervention inside of those. And the new automation is on average 2.5 times faster at detecting when a project has released a new version of software, so we can get it out to all of you faster. So in fact, now with this system, now that we know what versions of software are available when, we're finally able to address one of your longest standing requests for us, to put an SLA on new versions entering our catalog in the same way that we have an SLA on CVE patches. And triggering this is just the start, knowing that there's a new version of software being released. We still have to bump that software. We have to rebuild it. We have to retest it. We have to repatch it and get that out to all of you. And we have agents for all of that too. This technology is helping us scale our operating system faster and further than before with much tighter SLAs than we've ever been able to offer before, while keeping quality high too. So this brings me to my first announcement for today. As we've scaled the catalog of images, we've also scaled the operating system underneath it. A lot of the packages that we add to that operating system are directly required for those images. If it's a database server, we need that database package. But there's a lot of other useful software in that catalog too. Think things like database drivers, networking tools, debugging tools, even fonts. These are random packages that you probably don't need all the time, but when you need them, you really need them. And custom assembly has helped a lot of you get those packages into your images without having to take on a lot of toil, but it's not a perfect fit for every use case. And a lot of you already have tooling that you like to build and customize your images and do that last mile work to get these packages where you need them. So today I'm excited to announce a product designed just for that use case. Chainguard OS packages. This is access to the full set of packages that make up our images and everything beyond that, backed by this new version SLA. For a name, I like to say that we're the team that originally created distroless images, and we call this one imageless images. It's all the software in our images without the images themselves. It's the same CVE and supply chain guarantees for everything in this package repository, and you can use your own tooling, your own Docker files, your own AppCo YAMLs, Bazel, Nix, or other tools to assemble the images yourself. And if you're already a Chainguard Containers catalog customer, this is included free of charge. If you're getting containers from us, you now have access to this full OS package catalog for free built in, so you can build and customize everything you need. Chainguard OS packages is available today, and once again, it's included for free for all Chainguard Containers catalog customers. We're excited for all of you to try this and let us know what you think. So, while we're expanding the ways developers and DevOps teams can use Chainguard to build their own software and to embed it into their own software factories, we're also deepening our investments in our existing products. And I'm excited to welcome up our SVP of Product, Patrick Donahue, to the stage to share more on that front.
Good morning, everyone. My name is Patrick. I lead the product team here at Chainguard. I'm incredibly excited to be here with you at Assemble 2026. See a lot of familiar faces in the crowd. that I've met with in the 6 months I've been here. If we haven't met yet, would love to chat with you. I'll be here today and tomorrow. Love your feature requests. Love to hear what we could be doing for you. It's these customer conversations that really drive a lot of what you're about to see. So the best ideas come from you, and about to share some of those. So we're really just starting to realize the benefits of this Factory 2.0 that Dan mentioned. And I'm going to share some of how that momentum is driving forward containers and libraries. And you're going to hear more about new artifacts that are coming from us. I'm also going to tell you a little bit about where we're headed next. But before we jump in, I want to explain the agent loop powering the factory in one click deeper than Dan just went through. So as he mentioned, our agents are monitoring for drift from desired state. Desired state for us is that you have all the packages and artifacts that we're building as soon as possible from the time they're released upstream. So we want to drive that down essentially to zero over time. And so what causes these triggers to deviate from this desired state? Obviously, the things you might expect, new fixes available for CVEs, new upstream versions, but there's some other factors that play in here. When these agents find deviations, they're springing into action. They're consuming commits from upstream and unstructured data and trying to make sense of it, as Dan just showed you. For example, do we have a new release? Has the release tagging changed? Has the naming convention moved? When agents are able to figure it out, they're essentially rebuilding those artifacts, and then the things that depend on those artifacts are rebuilt over and over. And as I mentioned, it could be because of a code change. But also we see a lot of benefit. We're updating our build tool chains. We're improving our compiler hardening flags with projects like OpenSSF. Actually helped us last year proactively avoid a CVE, a 0-day in rsync. And so we're, of course, bringing the fixes from upstream. We're also taking action to rebuild the world in a way that makes you safer. And this is all done, of course, on our Salsa Level 3 hardened infrastructure. So when these packages are ready, they're pushed to our central repository. They're then replicated to your repository and made available for global distribution. We're also rebuilding your custom images that depend on these packages with custom assembly. And then so if after confirming that drift state, desired state rather, we go back to look for new drift. And this is similar to a Ralph loop for those familiar with the concept, with one key exception. When we get to the end and we're done, we expect things to push us off that state and rebuild. And so these agents are constantly running. There's no rest for them. So this year with the new factory, we've really been focused on accelerating the pace at which we are giving you new artifacts. We now have more than 2,200 projects where we're building all the versions that we can find of container images. Based on those packages, we have more than 30,000 packages in the catalog, as Dan mentioned. And this is an order of magnitude bigger than anybody else trying to do this in the space. We're obviously not stopping there. We know there's more that you want from us. And so we've released a new interface that lets you request that or lets your agents request that in our dashboard. You can today request container images, soon automatically libraries and other artifacts we're releasing. And our goal, again, is to drive this down so it's instantaneous. You make a request, our agents fire, they build this, and then you have it in your repository. Beyond container growth, we have a lot of really exciting updates for you. So Helm charts, most of you use them. I've talked to many of you about them. A lot of you depended on a third party that made a license change last year, went from open to closed source with kind of little warning. We stepped in, we forked those, we rebuilt those, we're maintaining those today. But there's a lot more that we can do within Helm charts. And so we're greatly expanding our coverage to hundreds of community maintained charts. And over time, we're going to take these two sets of Helm charts and move them towards a world where we are applying our opinionated security and productivity to work better with our Chainguard images. SBOMs, everyone's favorite topic, software bill of materials. Most people think of it as the nutrition list on a food label. We've always given you what the ingredients are that go into the SBOMs, but what about those byproducts that get built? From modules being pulled in as these artifacts are built. So we went a lot deeper with SBOMs, a lot richer data there. We've also implemented the Cyclone DX format in addition to SPDX, which we already had. SSL certificates or TLS, depending on when you started in the industry, everyone's favorite thing to do in a Docker file. Some of the conversations I had with you all over the past few months said, hey, when we're pulling an image from you, there's a bunch of things we do after. We'd love for you to take that on and do that for us. What'll make our lives a lot easier. Pulling certificates in is one of those things where you have to rely on somebody pulling the latest and making sure it's up to date. In this particular case, we allowed you to do individual certificates on a one-off basis. And now, as of yesterday, I think we released the managed bundles. And so if you need to trust AWS RDS or you need to work with the DoD PKI, you can just click a button and we'll make sure it's up to date in your image. Okay, so lastly, within containers, the expanded private APK repository. So most of you are taking packages today and extending existing images, not building new ones from scratch. If you are, Chainguard OS packages is for you. In this case, you might want to add curl or Postgres client library, whatever that may be. So we've made that accessible to all existing customers today to customize. Okay, another theme that I heard when I made the rounds was essentially, we're doing a lot of stuff for you to solve your problems, but you want it to be easier or more self-serve or automated to do yourself. And so you don't necessarily want to have to pick up the phone to make a request to do things. There's still a few things in our product today that you have to do that for. We are eliminating those entirely, but we also want to make it easier for companies just getting started with Chainguard to get going without having to pick up the phone. So this is especially exciting for me. It's because it's something that you can get going with today. We're calling it the Chainguard Catalog Starter. It's free for use. It includes 5 images, all the versions we build except for the EOL versions. It's a great way to get started with Chainguard. And later, if you want to add human-delivered support or SLAs or more features, pick up the phone and talk to us. But you can get started with this today. Another thing I heard was, hey, we've moved on to your container images, and our scanners are a lot happier. They're going from red to green and all the things that we've put onto your containers. And so this could be your first-party applications. It could be the third-party ones that you're building. Where you're starting to see the scanners light up now and where the sort of the next level that needs to be focused on are the commercial ISV products you're pulling in, whether those are VMs or containers. Most of these are built on third-party legacy Linux distros. And so a lot of them don't get updates. A lot of them are the kind of the core count of a lot of your CVEs. So you've been faced with the choice. You either accept and inherit that risk, or you try to manually rebuild them from scratch. To solve these problems, we're introducing Chainguard commercial builds. It's quite simply your favorite licensed software put on top of a Chainguard container. And they come with the full provenance, signatures, and CVE SLAs that you'd expect. Every time a new version is released, our factory is dutifully building it, packaging it up, delivering it to you. And all of this is going into the catalog for free. So if you're a catalog customer, you're going to get access to these. You have the ISV license. You'll be able to use these products. We'll bring the containers for you. So we've partnered with some really industry-leading companies that you can see on the screen here to package and distribute. If something you want to use is not there, please send them our way. Please talk to us. We've got a standard partner program now that we can onboard them, and we're excited to grow this commercial ISV group for commercial builds as broad as you need. So please let us know. And I'd love to welcome to the stage GitLab Field CTO George Kuchikov, one of our early commercial build partners, is going to tell us a little bit more about it. So, George, first hard-hitting question. We didn't coordinate these outfits, right?
Nah.
No, okay. Terrific. So I really appreciate you being here. GitLab is a name that I hear every day talking to customers. A lot of customers migrating to your product, very happy with it. But maybe some in the audience aren't as familiar. Can you share a little bit about GitLab?
Yeah, definitely. A lot of people think that GitLab is just another source code management system, but GitLab is the intelligent orchestration platform for DevSecOps that helps your team everything from code to deploy. We provide capabilities like planning and issue boards, code, build, deploy, secure, govern, and we have all different deployment models. Not just a lot of our competitors these days are moving to multi-tenant SaaS and cloud services. We have a lot of support for self-managed customers, including fully air-gapped environment, single-tenant dedicated, including dedicated for government with FedRAMP authorization. So one thing you mentioned earlier was that it's a lot of hard work to produce a hardened self-managed package. So we're excited about what's coming here.
Terrific. So what are you hearing from your enterprise customers? What are their expectations for commercial security software?
So what we're hearing is that AI is changing the game. Everything is moving so much faster. The speed is going 2x, 3x, 10x. So what matters is still the underlying software engineering fundamentals, but it's getting harder and harder to secure. It's getting harder and harder to govern. You have the right level of underlying controls, and governance is super important. Customers expect things like SBOM, provenance, vulnerability management, and as the speed of AI, as the speed increases with AI, it's really a struggle to get that going, and the risk increases, and customers want the vendors, their partners, to really help with that control and governance guardrails. This is our mission at GitLab, and this is why we're looking to partner with Chainguard.
So historically, customers have had to do a lot of that themselves, right? They've had to remediate and build and continue to do that as you release new versions. What impact does that have on you as a vendor when they're needing to do that?
Yeah, I mean, it's not only customers, it's ourselves, right? We spend a lot of time making sure our images are hardened, our packages are secure by default, and it's just a lot of operational overhead. A lot of operational overhead that our customers could be spending building their own software, building their own features that drive their own business. The other thing that we're seeing is that sometimes customers are behind on this, which introduces a lot of risk with these delays applying the latest vulnerabilities and patches. So GitLab's philosophy here is that we really want the security to be embedded in the software development lifecycle, everything including automated SBOM generation, vulnerability scanning, guardrails, governance controls, and really provide a seamless developer experience with security by default.
Great. So we're incredibly excited for you to partner with us. Would love to just have you share, what made you kind of make the decision as an early partner? Obviously, we've worked together over the years, but how would you sort of describe your impetus for working?
Well, one of the first things is that Chainguard is providing what we're hearing from customers, things like provenance, SBOM, a faster vulnerability patching and remediation. It allows us to deliver secure by default software without requiring the customers to do that extra work. And more broadly, it's creating a more transparent, standardized software supply chain for the industry that's benefiting both our customers and the vendors alike.
Terrific. Thank you, George. Really appreciate you being here. Thank you.
Thank you.
Okay, so that's enough about containers. I want to move on to libraries. Last year, Dan was on stage at Assemble introducing libraries, and spent an incredible year since then. A lot of whiplash as malware after malware got introduced. On the major registries, we heard from customers that were just absolutely scrambling when this malware hit. Where can they figure out what their developers have pulled down, and then how do they remediate that, and then how do they get secure by default going forward? Or worse, was their CI system compromised? And so we fielded a lot of these questions. We've been really investing here. Want to share some of the results of that. So the reason for this scrambling, of course, was obvious to anybody paying attention, just from a sheer volume perspective. There were more than 450,000 new malicious packages we saw in NPM, PyPI, Maven Central. That's almost one per minute throughout the course of 2025. Some highlights or some lowlights. The first self-replicating worm we saw in NPM was exfiltrating thousands of credentials. We saw libraries with almost 3 billion weekly downloads get compromised, and new popular AI models became victim to typo squatting attacks. So a lot going on the library side that we felt that we could come in and help with. And so if you're in a world where developers are prioritizing speed over security in some cases, they think that they're faced with a choice. You either have to slow down, as Dan mentioned before, and accept more or move fast and accept more risk, or slow down your innovation to stay secure. We think that's a choice that you shouldn't have to make. So in October of last year, we GA'd our Python libraries, and we've been really just on a tear trying to build the entire world of Python libraries. We're now up to 96% coverage on average. When we put the slide together last week, it was 94%. I think Dan Ryan, the engineering lead for this, is in the room. I think we'll get to 100% quite soon, he's told me, so really excited there. We've been building like really hard to rebuild libraries, and so AI libraries like PyTorch and Torch Vision and Torch Audio, so we've been really marching through Python. With Java, we've been building now more than 1 million unique versions of dependencies. Feedback from a lot of customers, especially in this area, was there are certain frameworks that you wanted to see to adopt this product. Frameworks like Spring Boot and Jackson and Apache Commons, and of course, everyone's favorite Log4j. And on the malware side within JavaScript, people are terrified of what's happening with NPM. We're building nearly 90% of the top 500 dependencies in their high impact list, which is almost 75,000 total versions. And the factory that we've been building to accelerate elsewhere, we started focusing that on Python. You can see the results there. We're moving on to Java and JavaScript with those AI building tools. One thing I noticed when talking to libraries customers is a little bit different than container images. Most developers are just pointing directly at the registry and pulling those dependencies in. Whereas you might be pointing to an Artifactory or a Cloudsmith to be able to download your container images, you're pointing upstream. And so when we started working with customers to implement and pull the libraries we were building, it was kind of a developer by developer machine. Obviously, you can point your CI to something central with a fallback, but for us, it was, okay, point to us. If we have it, we'll give it to you. Or if not, configure your client to go upstream and get it. So that was a little bit painful for some of you to adopt, and so we really wanted to make that a lot easier. So we built our own artifact repository. We call it the Chainguard repository. Again, very, very creative name. It's the safest source for your open source artifacts. It comes bundled with all the libraries that we're building, free of charge. So if you're a libraries customer, you get this. And it lets you set and enforce policies to remain compliant. And so if you want to be able to provide visibility to your security teams with this, you can do so. You'll automatically benefit as we continue to build that long tail of libraries. They'll just show up on your developers' machines. You don't have to actually change anything. So you point to us, and you give us your configuration, and we'll make you secure by default. Some of the things that customers have been really excited about are license enforcement, or maybe their legal teams have been excited about license enforcement. And so if you don't want to let copyleft licenses come in or whatever it may be, we'll take those policies on for you and then only give you what's acceptable to use. It's also a really good place to point your AI agents, right? So they're building software, and if you know that they're pulling from the Chainguard repository, they will be safe and secure by default. Perhaps the most requested feature as we started talking to customers about this was a cooldown period. We're releasing this for JavaScript to start. A cooldown period is quite simply, don't give me a library that's newer than X number of days. And the reason you do that for the ones that we're not yet building is oftentimes that malware is detected within a few days of release. And so whatever threshold you're comfortable with, you want to balance getting the newer versions with preventing malware. And so we've built in this cooldown period to start. Okay, so with the Chainguard repository, we are excited about improving and unifying the experience for you of how you receive secure by default artifacts, giving you policies that you need to manage your environment. Super excited to hear your feedback. We'd love to chat with you if you're interested. And really, really excited to continue to release efforts here. Okay, so we've heard what's coming in containers. We've heard what's libraries. I now want to hand over to one of our most innovative customers to talk about how they're taking advantage of this innovation. So let's welcome Dan back to the stage to moderate a conversation with Colin Estes. Colin is the technical director on NASA's mission enabling services contracts with MRI.
Thanks for joining us, Colin. Yeah, thanks for having me. All right, first question. I know everyone here is dying to know it. Was the moon landing real?
Yeah, I can unequivocally say that we landed on the moon multiple times.
Okay, I thought so. Tell us a little bit about the environment you manage.
Yeah, at MRI, we've been supporting NASA for close to 4 decades now. For the past 10 years or so, we've been building software platforms on Kubernetes. Thank you for all of our team uses Minikube. We're about 140 people at MRI, with 40 of those really dedicated to cloud engineering and supporting NASA's most dynamic missions, like our upcoming flagship telescopes, like the Habitable Worlds Observatory, or Artemis 2, which is launching here in a couple weeks. So I hope everyone will tune in and participate in that as we return humans to the moon.
Is Kubernetes in outer space right now?
Not yet. We are running containers on the space station, so we're one step away.
All right, soon. As software becomes more complex, especially with AI-driven workloads in your environment, how does that change what security means for your team?
Yeah, I mean, for us, it's like the dependency tree depth is just growing. The size of the images are growing substantially as we roll out, custom models in these things. And so, on our side, running these platforms, we just saw an explosion of CVEs over the past 2 years that ultimately really threatened our kind of continuous ATO models and our ability to deliver at speed that the mission required. We were, stuck in that manual churn, right? Like most of the people here, I'm sure, trying to play whack-a-mole with the CVEs and filter the signal from the noise.
So what was the aha moment that validated your need for Chainguard?
Yeah, I mean, that was it. It was, once we became a customer and saw the speed at which we were able to remediate and move forward, it was a no-brainer for us to just kind of go all in on attempting to Chainguard our entire platform. And over that time, we closed a huge churn gap and remediated far more than we would have been able to on our own, just trying to be good consumers of the upstream. So yeah, it's been a huge way that we realized we couldn't just patch and automate our way out of it. We needed someone to help us get, especially with FIPS compliance and those hardened image requirements that we have.
Well, I've got to say, it's an honor to be working with you and being a part of this program. Cool. Once you adopted Chainguard, what else changed?
So, I mean, for us, it's like the security kind of became a default on that front, and we were able to focus our SecOps on the other things, not just the image security, but the overall security of our environment and monitoring, and really moved our focus towards the places where we could add value. And so that's been a huge thing for us. Moving that, we've been a very auto DevOps and GitLab centric delivery models, but Chainguard kind of fit right into that mode and just allowed us to be effective really quickly.
So you expanded from Chainguard containers into Chainguard libraries. Why?
Yeah, I think it's a natural evolution, right? And especially with our move towards agents, like everyone else, leaning into the Python open source libraries and things like LangChain and LangFuse. Those dependency trees are just growing heavier and heavier. And once we kind of smashed the CVEs at the image layer, we turned our focus to those SAST and DAS scans and how we can continue to kind of drive that number to zero ultimately. Yeah.
It's crazy to see all the places Python has made it because of this surge in AI use cases.
For sure.
All right, well, thank you, Colin.
Yeah, thanks.
Thanks for joining us. All right, so we talked earlier about how we're using driftless and agents to scale our factory and make it faster for us to make our products better, add new products, and keep them more secure and keep them more up to date for you. Today in our OS, we're adding projects faster than ever, patching them faster than ever, and updating everything faster than ever too. We're also using AI throughout our entire development process to get you more features than ever, like the ones Patrick just shared. I have a few more announcements I want to talk through today too, though, that we've just built or are starting to build using our new Factory 2.0 infrastructure. So we all know that coding agents are changing the way we all work. They're changing everything from org design to the entire set of tools you use across your SDLC. The end result here of everyone chopping that much more wood and writing that much more code that quickly is putting increased pressure downstream on all the other tools in your SDLC that come after the keyboard. You and your agents can write 10 times as much code, but you can only ship as fast as you have confidence in the automated systems that move that code into production. To unlock this velocity and turn 10 times the code into 10 times the roadmap delivered, you need a rock-solid CI/CD pipeline. How many people are confident that if they send a PR up and all of the checks are green, they can click merge and send it straight to production? Not many hands. Yeah. Well, that's where we all have to go to turn agent velocity into roadmap velocity. But even when we get there and we figure all this out, CI/CD systems are fundamentally hard. They're often operating some of the most privileged parts of our entire stack. They have the literal keys to the production kingdom. They're the systems that move your artifacts from the artifact managers into production. They have the deployment keys. Recent attacks on them have made this clear to security teams, but they still remain some of the least protected pieces of infrastructure in all of our stacks. Every supply chain is a set of links, from keyboard to source to build to storage to deployment. And even before that, with things like upstream libraries getting pulled in, all having their own supply chains. And after that, if you're in someone else's supply chain. And every single one of these links can be infected and affect everything after it in the supply chain. And attackers are noticing this too, unfortunately. This isn't just a hypothetical. Going back to the original nation-state level Sunburst attack on SolarWinds, the sophisticated backdoor being planted in XZ utils after source code, the code cov or TJ actions breaches on CI/CD pipelines themselves to steal secrets, and recently all the AI-assisted attacks like HackerBot Claw that compromise security projects themselves like Trivy, along with countless other C and CF and enterprise projects. There have been large-scale breaches on pretty much every part of the software supply chain monthly for the last several years. And this isn't because developers or DevOps teams are lazy. They know this is hard. They know it's important. We just haven't given them good tools to work with on this stuff. So I want to show a few ways that this is hard, starting with one of the most popular CI/CD tools out there, GitHub Actions. To use actions securely, developers have to be able to trust that the actions they're using are coming from someone they trust, they haven't been tampered with, there's no malware, and that they're free of security misconfigurations. But it's really hard to do this today, even if you're trying. This right here is the actual GitHub Marketplace listing for the Claude Code GitHub action. How are you supposed to know that? Because it says the word official? None of the other ones here say official. This actually makes me more skeptical. Anyone can publish anything to the marketplace. If you double click in here and try to do a bit more diligence because you're really trying as opposed to just using it like someone else, we can see some more detail. We see that there are a lot of stars and contributors, but this can all easily be faked today with AI. Thankfully, though, there's a nice blue check mark. So let's click and zoom in there. Unfortunately, all this one really tells us is that GitHub has verified that this comes from an official partner. It doesn't tell us which partner, and pretty much anyone can become an official partner. It also doesn't tell us what security practices the partner happens to follow. And if we squint and look at the GitHub organization this one comes from, you might think that we just discovered a massive typo squatting attack in practice today. Who is Anthropics with an S? Thankfully, that does actually turn out to be Anthropic. This nice-looking gentleman here has the Anthropic GitHub account. Let's all hope he doesn't sign up for the partner program and start publishing things. This stuff is incredibly hard to get right, even if you're trying to do your best and review all of this before you pull it in. It's almost impossible to tell what's safe to use. And again, this is wild because CI/CD pipelines are some of the most important pieces of infrastructure today. But we're all going to need to rely on it to unlock agentic development, and we're going to need it to be rock solid. So today, I'm excited to announce Chainguard Actions. These are secure by default drop-in replacements of upstream GitHub Actions for your CI/CD pipelines. They let your developers and agents ship fast without taking on supply chain risk in the pipeline itself. They're designed to eliminate both types of risk we just talked about, misconfigurations and malware and third-party actions. They let you rely on a single trusted source to get all of your GitHub Actions from, and they're exactly compatible with what you're using today. They're built using our Factory 2.0, which is already letting us move faster and make things safer for all of you. Today, we have over 100 of the top actions from the GitHub Marketplace, with dozens of hardening fixes applied to them to make them easier to use without worrying about security risk. Let me walk you through it. This is how it works. It's another reconciliation loop like the one Patrick showed earlier. It's a fully automated pipeline using our driftless framework. We ingest the upstream actions from their GitHub repositories where they live, and we run them through a series of checks. The first thing we do is grab that action, and we generate tests for it. Not all actions have great test coverage, and we want to be rock solid that we can modify it and harden it without breaking anything. So our agents find it, they clone it, they strip out everything unnecessary but the action itself, and then they generate those tests. After we have sufficient test coverage for every single action, then we scan it again, looking for security misconfigurations. And then we apply those hardening fixes, ensure those tests continue to pass, keep iterating until it's fully hardened, we know it's still working, and then we publish it. The checks that we look for address most of the common action security issues. This includes things like shell injection issues that led to the big HackerBot Claw attack on Trivy and those other projects we talked about earlier. We also pin all of the dependencies inside of these actions, making it so your supply chain can't drift on you without you realizing it. We go deep and pin everything in here, including unpinnable actions, which was some research published by our friends at Palo Alto Networks a couple years ago. After we've identified all these risks and mitigated them, we publish them and make them available in the Chainguard Actions catalog for all of you. We have hundreds available today, and we're building more every day. We're excited to see what you try with this, and we're excited to get these in your hands so you can move faster and safer. To double click in on one example of a hardening fix that we applied. This is in that Claude Code GitHub action originally. There's shell injection here. These are a bit hard to exploit, but until you know how these are being used in downstream systems and actions are chained together, untrusted variables can make their way into these scripts and compromise tokens. This is exactly like what happened with HackerBot Claw. To deploy this, it's as simple as swapping the organization you fetch your GitHub actions from. A string replace for everywhere you're getting them today, replace that with Chainguard dev. And then you can add a single rule inside of your GitHub settings to restrict people to using only these. We're excited to continue scaling this up, and we know that everyone here is investing a lot in their CI/CD systems over the next year. That's the only way you're going to be able to unlock all of that agentic velocity. With Chainguard Actions, you can focus that investment on making the CI/CD system run faster and have more confidence in the checks, and not have to worry about securing the infrastructure you're building on. Chainguard Actions are now available in beta alongside all of our other products, containers, libraries, VMs, and OS packages. We're now protecting your entire runtime stack and the CI/CD pipelines you use to deploy them. So now you can see why we had to set this projector up in the super wide format. But that's not all. CI/CD is a huge threat, and it has been for years. It's growing in importance with all the stress placed on it because of all the new agentic tooling. But AI is also introducing new formats and ways of working that are growing even faster than this. We've been investing and experimenting with everything in this space from the early days. Last year, we released hardened MCPs. A few years ago, we released hardened CUDA images. But more recently, skills have popped up as the de facto way to store and share knowledge and iterate and improve agentic systems. We've also been using them a ton across our development and Factory 2.0 infrastructure to codify that expert human knowledge we have and improve the factory over time. If you happen to blink and not refresh Hacker News every 15 minutes over the past couple of months, you might not have seen skills. They've risen so quickly. So I want to step back and explain what they are and how they work. Skills are basically just a standard markdown format for encapsulating a set of knowledge, tools, and resources for agents to perform specific functions. They're supported everywhere now, pretty much any agentic tool, from Codex to Copilot to ChatGPT to Claude Code. They're incredibly powerful, but at the end of the day, they're just markdown files that are executable by all of your agents. They can pull in their own tools, they can download things from the internet, and they can run with permissions on your laptops or in your systems. And unfortunately, like all fast-moving spaces, this one got the attention of attackers pretty quickly, too. We used to have a couple years to play around with a new piece of technology before attackers found it and ruined all of our days. Those days are gone. In the first few weeks of skill marketplaces going up, attackers found ways to inject malware and exploit malicious configurations in them. We want to help your teams go as fast as they need to keep up with this new world without having to worry about the risks. That's why today I'm excited to announce our next product, Chainguard Agent Skills. It's a hard and secure by default collection of drop-in replacements for upstream skills, just like our Actions product. They're purpose-built by our factory where they're ingested, tested, hardened, and kept up to date automatically. They're designed to stay always up to date with the latest skills from all of the major skill repositories, and they provide you with a reduced attack surface and a malware-resistant platform. Today, we have hundreds of skills available, updated daily with dozens of hardening fixes applied to them. We want to let your teams try the newest and best tooling in the agentic world without having to worry about security or having to slow down. So let's get into how we build these. Just like Actions earlier, they're all built using that reconciler-driven Factory 2.0 architecture. We grab and ingest popular skills from skills.sh, skills.mp, and other skills marketplaces. We generate test cases to ensure we can confidently modify the skill. Then we check these with a set of agentic and deterministic scans. And we incrementally harden every one of these skills until it passes our tests, and then we publish it to our repo. Skills move very fast. These are updated daily, so our bots continuously check for new versions, re-ingest, retest, and re-harden them to make sure we always have the latest versions available. Here's some of the hardening fixes we've applied. This includes things like narrowing allowed permissions to things the skills should be able to do based on their scope, not everything they happen to ask for at the time. There's a lot of bash ** permission requests in these ecosystems. We pin the contents here too to reduce the chance of remote code execution. This first example has over 150,000 weekly downloads and 22,000 GitHub stars. It also has some pretty glaring issues in plain sight. The original skill here for web design guidelines didn't actually contain any rules or contents on its own, It just instructed the agent to fetch the actual contents from a remote GitHub URL. They could change out from underneath it at any time. Our fix, inline all of that, scan it, and then harden it so it's pinned and it can't change out from underneath you. The second one, here's another fun one. At the initial time of ingestion, there was nothing wrong with this skill. It was safe. A version that was released a couple days later, though, introduced risk. It started downloading random binaries and executing them without any integrity checks. We're able to keep up with the pace of the skills ecosystem and give you a single set of trusted, hardened skills that you can use across all of your tooling. Chainguard agent skills are now available for free for all existing Chainguard customers. They fit alongside our existing products like containers, libraries, VMs, the OS packages, and actions. So please reach out if you'd like to give these a try. Now we're securing the code behind all of your infrastructure, CI/CD pipelines, and your agentic stack. We're really going to need a bigger slide here if we keep going. Should we keep going? Okay, we'll keep going. I'm really excited about everything we've announced today, from the new features in Chainguard images, to the scale we've hit in libraries, to moving closer to artifact management with Chainguard repository, and securing new types of open source like actions and skills. This has all been possible because of the investment we made in our infrastructure, in Factory 2.0, which lets us keep humans in the loop while leveraging agents to scale our work. But I don't want to stop there, and we don't want to stop there. That same automation that we built to manage and build and maintain the long tail of open source in a scalable and secure way could also be useful to all of you. So what if that same Factory 2.0 infrastructure that lets us run agents and harden software at scale could be used by all of you directly? What if we could automatically find places you're not using our software and migrate you to it in your own CI environment? What if we could keep your library dependencies up to date automatically, generating test coverage where you don't have enough, so that way when we do those updates, you can be confident that fix can go to production? What if we could automatically detect anti-patterns in your CI/CD system and fix them for you, just like we're doing with Chainguard actions? Today, our hardened open source catalogs are the finish line, but we know firsthand how much work goes into using these even after you've migrated to them. And that initial migration isn't always easy either. I'm talking the continuous scans, the dependency and system updates, and building a CI/CD system that you are confident in. So when you see green, you're ready to merge to production and you know things won't break. The Factory 2.0 tooling we built is useful for more than just us, and we want to open it up to all of you. We want to share how we leverage agents securely across the entire SDLC with everyone else. But to do this, we'd obviously first need to come up with a name that matches the vision of what we were trying to build here. And that's why I'm incredibly excited to announce the Gardener. It's our factory and agentic automation for managing and securing our open source and SDLC, now available for all of you to use. Gardener's our own agentic factory, continuously taking care of all the code you didn't write available directly to you. It can migrate, update, test, harden, and automate the long-term maintenance of all of the open source software in your stack. The same way we bump dependencies safely, testing the app layer code and applying fixes if needed, if APIs have changed. The same way we author all of our configurations to fully pin container images, and then detect and test and bump and roll out new versions of application layer images to our production stack. The same way we structure our image builds to cut unnecessary attack surface while keeping everything needed to build and run your apps themselves. Same way we're continuously ingesting and hardening GitHub Actions to reduce common exploits. Same way we're auditing skills for security issues before integrating them into our factory. This all sounds pretty abstract, so I'm going to jump into one use case that's available now, migration. The Gardener hooks up to your GitHub app, your GitHub repository as a GitHub app. It looks at your source code, it looks at your tests, it looks at your Docker files, and it detects places you're not using our images today. So if you're an existing Chainguard customer still working on a wall-to-wall deployment, it can find all of the places you haven't deployed our software yet, and it can do that migration for you. It can send a PR, generating tests to make sure that it works, and iterating on that PR until it's green, all in your own stack, in your own source code repository, in your own CI/CD system, with your own tests. If you're not on distro list yet, we can take care of that for you too. We can turn even the messiest Docker files into clean, slim, hardened, multi-stage CVE-free ones. Again, all with your own existing tools and system. This is our take on a fully agentic supply chain and factory. All the extra work you have to do today to take care of, maintain, and adopt open source, even after migrating to Chainguard, can be automated. We want you to tell the Gardener what to do, let our agents do the work, then click merge when the PRs are green with the same confidence we have today. It's like putting your open source software supply chain on autopilot. Okay, this slide can't possibly get any bigger today. We're done for now, I promise, and we'll figure out a different format for our next conference. Just like everything else, this is all powered by Driftless and our Factory 2.0 architecture. But a Gardener sits a level below, and it'll manage all of the other products that we deliver for you today. The Gardener is available now and can help anyone get on board with Chainguard images. But we have a lot more to do here, and we're excited to work with all of you to learn the best ways to integrate this into your tooling, your build systems, your SCM, and your artifact managers. So reach out if you want to be a part of this with us. The future is clearly here, and we feel it every day. We're so lucky to work with all of our customers and all of you here in this room to help us figure out what to build and to help us shape our products and our roadmap. Open source isn't going away, and AI and agents are here to stay. We all have to figure out how to integrate them safely. We want to be with you on this journey, and we're thankful for all of your support and trust. I want to thank you all for joining us today and helping us build the future. Let's hand it back over to Liz to wrap us up for the morning.
Incredible. In case you lost count, that was 7 product announcements. Unbelievable. The future of secure software development is changing by the day, but it's clear that the way to be prepared is a secure by default foundation. And Chainguard can help you with that. So before we go to the next session, I want to take a moment to thank our sponsors. Thank you for making this possible. And here's the agenda for the rest of the day. Right after this, we're going to go to breakout sessions. You're going to go directly to the breakout sessions. You can see the agendas are sort of throughout the space. There's some printed ones and available online. Following that, we're going to have lunch. During lunch, you can go to some of the demo stations and learn more about the new products. You can give feedback on existing products. Stop by all the sponsor booths and make sure you grab some swag. That's why we're all here, right? In the afternoon, we'll have some more breakout sessions, and then we'll be right back here to wrap up at 4 p.m. for the Guardian Awards and a special session with Saturday Night Live's Colin Jost. So I'll see you back here at 4. Thank you.